Kamusta na mga ka-addict? You will see in this video how simple and easy to wire a 12 volts brake light on a high brake signal wire of a BLDC controller. To make it happen, a DC to DC step-down converter will be needed. Let's get started. To make this tutorial fast and quick, I connected some of the necessary wires beforehand. These two are the power line wires, positive and negative, connected to the battery. Red wire is the positive and the black wire is the negative. These two wires connect the battery and the controller for power supply. These are the motor phase wires. We got the whole sensor wires connected to electric lock wire or switch wire to power on the controller. Simply link or connect the electric lock wire to the positive power line wire. I made 2 tutorial videos on how to wire the key ignition switch kit. These tutorials are related to the electric lock wire. You can check the links in the description. And always use a fuse or a breaker for safety purposes. The breaker can also be used as a kill switch. And of course, a throttle for this tutorial. In a BLDC controller, usually it has high brake and low brake signal. Both have the same function, to cut power to the motor or to override the throttle that make the motor stop from spinning. The high brake signal uses high voltage, normally 12 volts or the actual voltage of the battery. In this video, I am using a 72 volts battery pack. While the low brake signal uses a ground wire and a positive 5 volt signal wire. The ground wire must be connected to the positive 5 volt signal wire. Check the complete tutorial video on how to wire the high and low brake signal. The link is in the description. The advantage of the high brake signal input is you can link or connect to the 12 volts brake light wiring because the high brake signal input will work on 12 volts or the actual voltage of the battery. This is a 12 volts taillight. To be able to use the taillight on a 72 volts electric scooter unit, you will be needing a DC to DC step-down converter. This device converts DC voltage ranging from 48 volts to 96 volts into 12 volts 25 amp 300 watts output power. These two wires are the input line wires. Black is the negative and the red wire is the positive. While these two wires are the output line wires. The color blue wire is the negative and the yellow wire is the positive. You can use the Google Lens to translate the label written in Chinese to English. I temporarily extended the input and output line wires of the step-down converter with alligator clips for easy connections. These two color yellow wires are the turn signal lights, and the blue wire is the tail light. These two are the only wires we need for this tutorial. The black wire is the negative or ground and the red wire is the brake light positive line wire. The black negative input line wire of the step-down converter should be connected to the negative power line wire that connects the battery and the controller. While the red positive input line wire of the step-down converter will be connected to the positive power line wire. Next are the output line wires of the step-down converter. Connect the blue negative output line wire of the step-down converter to the ground or negative wire of the taillight. I provided a brake lever with built-in switch for this tutorial. It has two wires, black and yellow. This time, the yellow positive output line wire of the converter will be connected to one of the brake lever switch wire, either yellow or black wire. And then the other wire or black wire of the brake lever switch wire will be connected to the red positive wire, which is the brake light. The step-down converter, brake lever, and the brake light are now linked or connected to each other. Now time to link or connect the high brake signal input wire. This is the positive line wire between the brake light and the brake lever. This is where you need to link the high brake signal wire. Finally, all wirings are done. Once you squeeze the lever, the built-in switch of the brake lever will close the circuit and allows the current to flow. Each time you squeeze the lever, the brake light turns on and the motor stops from spinning. As you can see from the diagram, the step-down converter is connected to the main power supply, which is 72 volts. The step-down converter reduces the voltage, resulting 12 volts, 25 amp, 300 watts output power for the brake light and high brake signal. Thanks so much for watching. Please don't forget to support my channel by liking, commenting, and sharing all my videos. At syempre maraming salamat. Muli kayong naligaw sa channel ko. Ride safe lang palagi mga ka-addict.